number 21NS0167, a BSc Physics 2nd Sem student of Sikkim Government College, Namchi, South Sikkim. And I am here to talk on the topic Newton's ring. So let's begin the video. Newton's ring. The phenomenon of Newton's ring, named after Isaac Newton, is an interference pattern caused by the reflection of light between two surfaces, a spherical surface and an adjacent flat surface. When a parallel beam of monochromatic light is incident normally on a combination of a planar convex lens and a glass plate, a part of each incident ray is reflected from the lower surface of the lens, and the part after refraction through the air flow between the lens and the plate is reflected back from the plane surface. These two reflected rays are coherent, hence they will interfere and produce the system of alternate dark and bright rings. The next we have is the basics interference. Interference occurs between the two waves that interfere constructively if path difference between them is m plus 1 by 2 lambda, and destructively if path difference between them is m lambda. Next, when viewed by monochromatic light, a series of concentric alternating bright and dark rings centered at the point of contact between the two surfaces. Next, when viewed by white light, concentric ring pattern of rainbow colors because the wavelength of light interfere at different thickness of the air layer between these surfaces. Other observation: light rings. Concentric interference between light rays reflected from both surfaces. Dark rings, destructive interference. Also, the outer rings are spaced more closely than the inner ones. Diagram: when a plano-convex lens with its convex surface is placed on a plain glass sheet, an air film of gradually increasing thickness outward is formed between the lens and the sheet. The thickness of film at the point of contact is 0. What really happens? Formation: Newton's rings are formed due to interference between the light waves reflected from the top and bottom surface of the air film found between the lens and glass sheet. Explanation of phenomenon on basis of wave theory of light. Number 1. An air film of varying thickness is found between the lens and the glass sheet. Number 2. When a light ray is incident on the upper surface of the lens, it is reflected as well as refracted. Number 3. When the reflected ray strikes the glass sheet, it undergoes a phase change of 180 degrees on reflection. Derivation of the formula. Here we have taken a small circle with dotted lines and we have marked the points capital A, capital B, capital letter C, capital letter D, E, capital letter R, and we have taken the distance between capital A to B as small t, and we have taken the distance between A to C as 2r minus t. And we have taken the distance between D to B as small letter r, and again we have taken the distance between B to E as small letter r. Now let's see what does these alphabets mean. R mean radius of curvature of convex lens, small letter r radius of ring, L wavelength of light. After reflection and refraction, two rays 1 and 2 are obtained. These rays interfere each other, producing alternate bright and dark rings. At the point of contact, the thickness of air film and the path difference both is equal to 0. As a 180-degree path difference occurs, they cancel each other and a dark ring is obtained at the center. Why dark ring is obtained at the center, we will discuss about it at the last. So next, let's move to next topic, derivation of the formula. Here also we have taken the same diagram as before. So as we move away from the central point, path difference is also changed and alternate dark and bright rings are obtained. Let us suppose that the thickness of air film is small letter t. By using the theorem of geometry, BD into BE equal to AB into BC. We have taken BD equal to small letter r in the figure. So in place of BD, we will write small letter r into, we have taken again BE as small letter r, which is equal to AB. We have taken AB as t into BC as 2r minus t. Now r into r, we have r square, which is equal to t multiplies 2rt minus t into t square. Since t is very small as compared to r, therefore we will neglect t square. So we have r square as 2rt. R square equal to 2rt. Let's mark as question 1. 2t equal to m plus 1 by 2 lambda, equation 2. For first bright ring, m equal to 0. For second bright ring, m equal to 1. For third bright ring, m equal to 2. For nth bright ring, m equal to n minus 1. Putting the value of m in equation 2, we have 2t equal to n minus 1 by 2 lambda. So 2t, from 2t, 2 goes to the denominator. Now we are left with t equal to 1 by 2 n minus 1 by 2 lambda, equation 3. Putting the value of t in equation 1, we get Rn equal to root under r lambda n minus 1 by 2. Meter formula. This is the expression for the radius of nth bright ring, where Rn equal to radius of nth bright ring, n equal to ring number, r equal to radius of curvature of lens, lambda equal to wavelength of light. More on the theory involved. Moving outwards from one dark ring to the next increases the path difference by the same amount lambda, corresponding to the same increase of thickness of the air layer lambda by 2. Since the slope of the convex lens surface increases outwards, separation of the rings gets smaller for the outer rings. For surfaces which are not convex, the fringes will not be rings but will have other shapes. Application of Newton's ring. We have two applications of Newton's ring. First one is, using the methods of Newton's ring, the wavelength of a given monochromatic source of light can be determined. The radius of n dark ring plus n plus m, the dark ring, are given by Rn square equal to nr lambda and r square n plus m equal to n plus m r lambda. Now Rn square come to the left side, so Rn plus m square minus Rn square equal to mr lambda. So lambda equal to Rn plus m square minus Rn square by mr. Second application of Newton's ring. Using Newton's ring, the refractive index of a liquid can be calculated. Let lambda A and lambda m represent the wavelength of light in air and in medium liquid. If Rn is the radius of n dark ring in the air, and if Rn is the radius of the n dark ring in liquid, then Rn square equal to nr lambda A, r dash n square equal to nr lambda m equal to nr lambda a by mu. So mu equal to rn square by r dash n square. Now some question based on Newton's ring, which people asked, why is the center fringe is dark, or why is the center of Newton's ring dark? Answer: the center fringe in Newton's ring is dark in the case of the reflected system because the air film thickness formed at the center between the glass plate and the lens is 0. Hence, at the geometrical path difference between the incident and reflected rays from the glass plate is 0. But due to reflection, a path difference of lambda by 2 is introduced. This path difference gives disruptive interference at the center, and hence center is dark. Why Newton's rings are circular in nature? Newton's rings are circular in nature because the air film is symmetrical about the point of contact between the plano-convex lens and the glass plate. Next question: what is the function of the 45-degree inclined glass plate in Newton's ring? Newton's rings are alternate dark and bright rings formed due to the presence of air film. When the plano-convex lens is placed on the glass plate is called Newton's ring. The angle between the incoming ray and the glass plate is 45 degrees to make turns the light ray to 90 degrees, and that's why the rays fall normally on the plano-convex lens finally form circular ring. Next question: where do the fringes form in Newton's ring? Is it on the glass plate surface or the surface of the convex lens? Answer: in Newton's ring experiment, the fringes formed are called rings rather than fringes, as they are circular in shape rather than being straight. These rings are formed neither at the surface of the glass plate or that of the convex lens. These rings are formed in the air gap in between flat glass plate and the convex surface of the convex lens. Most often we use a plano-convex lens rather than a double convex lens in contact with the flat glass plate.